Historically, public space agencies have defined space exploration. As of now, in 2022, 77 countries have space agencies.
For the first sort of 50 years of NASA's existence, NASA was the customer and the private sector was the supplier.
Now, billionaires are fundamentally changing the public's relationship with space.
We've seen the rise of a lot of small companies and startups like ours that establishes a whole ecosystem.
And a booming space economy in Colorado and beyond is really starting to take off.
Moving manufacturing off of our planet, creating opportunity and future for everybody, that's what I want to see.
I'm Cray Novick.
And I'm Myrna James.
It's time to go behind the wings. So in this episode, we're going to explore the question, how is the growing space economy changing what's possible in space? To start, we talked with Phil McAlister, NASA's director of the Commercial Spaceflight Division for Space Operations.
When we first started talking about shifting some of the responsibility for low Earth orbit onto the private sector, I think there was definitely a sentiment within some parts of NASA that we were giving up something that was special and core to our mission. And over time, I think that sentiment has really reduced as people have realized that if we were always limited to NASA's budget for what we could do, we would always be somewhat constrained. For the first sort of 50 years of NASA's existence, we kind of interacted with the private sector one way, which is NASA was the customer and the private sector was the supplier. So we would write very detailed requirements, we would make all the decisions about the spacecraft or the transportation vehicle, and then we would hand those to the private sector and say, go build this. And we would be sort of in charge, we would make all the decisions, and we would own the resulting hardware. But today, what we found is the commercial space industry, which is an industry looking to sell not just to the federal government, but to other organizations and to other just consumers. When you have a thriving commercial space industry, it doesn't necessarily make sense for NASA to build everything from scratch. We can leverage the capabilities in the private sector. That's kind of what we mean by commercial space. And I think just within the last 10 years, these kind of partnerships have become possible.
Previously, the space industry has been very large company driven. You've got your large primes and government contractors, and that was how it was for 50 years. As technology has increased and as the price and cost of getting to space have decreased, that has enabled many more businesses that now can close their financial model. You've seen the rise of a lot of small companies and startups like ours who see needs in the market and needs that the industry has, and we're able to meet them in ways that larger companies it might be more difficult to. And so that establishes a whole ecosystem of everything from single-person startups all the way up to 1,000-person companies.
Dylan Taylor, thank you so much for being here with us. You, I think, have more passion for space than anyone I've ever met. So you're currently the founder and chairman of Voyager Space Holdings. Tell us a little bit about the company.
Voyager Space is really purpose-built to help scale what we call new space, which is the innovative entrepreneurial sector of the space industry.
There's obviously a lot of collaboration in space, but what role does competition play?
Well, I think the market forces help, right? I mean, I think SpaceX was born out of competition with the Russian Soyuz rocket, with Boeing, with Lockheed, and because of that, they were able to attract third-party capital and invest and innovate. So I think it's really important. I think the market forces work. When space was purely a nation-state opportunity, you didn't see the level of innovation. We certainly didn't see rocket reusability. And now we even have things like launch as a service, where customers just simply pay to be inserted into a particular orbit. We are in a renaissance for the industry. The level of innovation is just shocking, and I expect more to come.
This is a graph of the investment totals in space. Just look at that graph. I mean, it's straight up practically. In the past 20 years, the global space economy it's grown from just over 1 billion to over 16 billion. That's huge.
Yeah, in investment in space, private space companies.
And then to get a sense of where this is going, this is looking at the future. Here we are, 2022, and the chart just goes straight up.
So the global space economy is expected to grow 4.5% in the next 25 years, and that's exponential growth, and it's not going to slow down anytime soon.
When you look at it like this, it makes it seem like we're really just at the beginning of things today.
Mm-hmm.
So we made our way to Lunar Outpost to learn how they're using technology originally developed by NASA to test for lunar dust to actually improve air quality here on Earth. Now that might sound a bit confusing, but we're going to talk to their CEO, Justin Cyrus, to learn exactly how.
My name's Justin Cyrus. I'm the CEO here at Lunar Outpost. It's been a very good past couple years for startups in the community, because now instead of just straight competition against the likes of some of the big names like Lockheed Martin, Northrop Grumman, or Boeing, they're looking at ways that they can work with small startups like Lunar Outpost and Outpost Environmental to innovate quicker and to not only bring value to the aerospace community and what we're doing out in cislunar space, but to find ways to bring that technology that costs a lot of money to create back here to Earth. So NASA spin-offs are technologies that originally were funded out of NASA or a part of a NASA program. And what these spin-offs are is commercial companies working with NASA to find ways to take this tech that folks have spent a lot of time and money on, and finding ways it can benefit life here on Earth.
So speaking specifically about the Canary Sensor now, we actually have one of them right there behind you. What was the original application of the technology?
So the original application of the Canary Sensor technology was actually to detect lunar dust. So it's called lunar regolith, and it's extremely fine dust. And it's harmful because of the chemical and geometric composition to not only humans, but robotic systems and space stations.
What was that technology transfer when you realized, okay, maybe this tech could be useful to improve life on Earth?
Some of the key core technology is detecting a particle and figuring out what's in that particle, or detecting just what's in a concentration of air. So what we do with the canaries actually here on Earth, actually figure out what's in the air real time out in the field. One of the use cases that was highlighted by City and County of Denver was putting it next to schools. So figuring out how we can improve the air quality for kids in elementary school, middle school, and high school, and the effects of the study are still being seen today. We were able to collect real-time data, and air quality was worse than you would want it to be, especially for elementary age kids at some of these schools. So that's just a small sample of what City and County in Denver was able to do with the air quality data we collected. The first day we actually put a canary on an oil and gas site, we found a methane leak within 7 minutes, and that leak was fixed within the first 2 hours. Whereas the historical way of doing it would have been months later until they found that leak. And at that point, thousands of liters of methane would have already been dumped into the atmosphere.
If you don't measure, you'll never know. And with the Canary Sensor, it's just that extra layer of data.
I think that's very well said. If you don't measure, you'll never know. And if you don't know, you can't fix it. And certainly that is what we're trying to accomplish by providing data not only to the companies, right, the oil and gas, the chemical processing, but also to the regulators so they can make sure the air we breathe is safe, healthy, clean. Because we have a lot of really cool tech that we're working on in space that can be brought here to Earth and applied in those markets. And what that strategy has allowed Lunar Outpost to do and accomplish is to reach some of our more ambitious goals of putting a rover on the moon, of making oxygen on Mars, while still driving profit, revenue, and having that strong near-term positive impact that can be seen from the Canary Sensors.
There are thousands of spin-offs from NASA, many of them that we use every day.
Things like sunglasses, rechargeable batteries, even sneakers.
Hundreds of NASA spin-offs have come directly from the International Space Station. We spoke with former astronaut Scott Kelly, who spent nearly a year on the ISS.
I think there are things we get from the space program that are valuable to our life on Earth. If we didn't have a space program, we wouldn't have these cool cell phones in our pockets that we look at all the time. So there are a lot of those kind of technical things we get from it.
The space program has created great benefits in terms of technology, spin-offs for use on Earth. I mean, one of the most obvious is actually solar power, which some people think will be our salvation from global warming. Solar power was developed as a really usable technology for use on spacecraft, because if there's nothing further off-grid than a spacecraft. And my little company has also spun stuff off. We were interested in making fuel on Mars that required capturing CO2 out of the atmosphere, and a number of other technologies. And it developed our gas capture technologies for a number of purposes, one of which has been to capture gas being flared by oil wells so that they could be trucked off to market instead of being flared. And another was capturing CO2 out of fermentation vats so that breweries could use the CO2 from their own fermenters instead of having to buy CO2 from industrial sources while venting their own CO2 to the atmosphere.
Here we are at the Denver Beer Company. We're going to learn about tech transfer from NASA, and they're creating technology where they're learning about resources that we have and how to use them here on Earth. So you're wondering, space, beer, how do they come together? We're about to find out.
When the beer's fermenting, there isn't really a great way for small craft breweries to capture that CO2 until Earthly Labs invented this CC machine. And so they licensed this NASA technology, which allows us to capture the CO2 during the fermentation process, bottle it up, and then we can reuse that CO2 later in the process, or sell it, or do whatever we want with it.
All right, so let's go check it out.
Okay, let's go check it out.
Great.
We've installed some piping that pipes the CO2 into the CC machine, where it's filtered, cleaned, cooled down, and compressed, and then put into a big 750-pound container. It tells us how much CO2 it's captured, the pressures, the temperatures, and everything that we need to know to run it.
Our third partnering business came in, and actually an indoor agricultural business who needs CO2 for the production of plants. So by partnering Denver Beer Co., who generates CO2, with another business who utilizes CO2, we were able to get through the pilot program. It was wildly successful. Really what we hope to see is a snowball effect, that people look to this as an example that other breweries can say, I should be capturing my CO2 as well. Space has limited resources, but I guess our planet does too.
Sort of like you can't really ship things to the ISS all the time, or to the moon, or to Mars. So they need many, many ways to utilize resources that are already there. So that's what the in situ resource utilization really is.
So thinking about this increase in public-private partnership, we've talked a lot about the startup side, but what does it enable NASA to focus on?
The public-private partnerships not only allows the aerospace community to reach these business plans that wouldn't otherwise be possible, but it also allows NASA to reach far greater goals than they could otherwise. A great example is the Artemis program. Getting humans to the moon on the budget that NASA currently has is not possible, it's not feasible without the public-private partnerships that have been put in place. But in addition to that, NASA is the cutting edge of space agencies around the world, right? They're looking at not only getting to the moon, but further getting onto Mars and exploring other planetary bodies in our solar system, and with the James Webb Telescope, many solar systems beyond our galaxy that would not otherwise be possible if they weren't working with the commercial industry.
By being able to shift some of this responsibility and have the private sector pick up some of these costs, we can go further, faster. And I think there's always going to be a role for NASA. That's our job, is to push the bounds of exploration where you don't necessarily see an economic potential. It's really just been over in the last 15 years that we've seen these very, very successful partnerships. And now, particularly with the Crew program, we have seen all kinds of benefits from that. Just within the last 12 months, we've seen an all-private mission just to orbit, the Inspiration 4 mission, which was really remarkable, first time in history. And now today, we have 4 private astronauts on the International Space Station, living and working in space on the ISS, another thing that is a historical first. And I really do think we are at an inflection point with human spaceflight, and it's really about to take off.
Skip, I'm Cray, pleasure to meet you.
Nice to meet you.
Let's talk about space.
Yep, sounds good.
Let's do it. We're almost in this new era, this new space economy. There's more private companies than ever. They're collaborating with national space agencies. How has that impacted space law?
Well, a couple of things that are happening now. I represent a private astronaut who's going up. It's a SpaceX flight up and back, and NASA hosts the private astronauts, and a company down in Houston called Axiom Space put it together. It was really a first of a kind contract. You can imagine a lot of legal issues associated with sending a private person up into space for 10 days. You know, this isn't a suborbital flight of 6 or 8 minutes. This is 10 days up in space.
Thanks to our SpaceX team for getting you there. My thanks to NASA for hosting us, and to the entire crew. You know, we've been talking about this history-making mission for a long time.
So you've got private astronauts going up now to the International Space Station, and you've got NASA planning for commercial space stations before the end of this decade.
The ISS is getting old, and we would like to retire it by 2030. That is NASA's policy right now. So the good thing is that gives us a little bit of time. We are currently working with 4 partners to design, develop, and hopefully deploy prior to 2030 their own commercial space stations. And the long-term vision, I believe, at NASA is that I will be able to just buy a ticket, just like anybody else, and go up to a destination in space, do my work, and come back down.
Right now, we are on contract with NASA for a commercial destination free flyer contract to start developing these commercial space stations. We're actually teamed with Blue Origin, and we're developing this space station, and we're calling it Orbital Reef. Think of it as a business park in space. Businesses come in, you provide the ecosystem, the power, the modules, the research facilities or the manufacturing facilities, tourist facilities, media, filmmaking, all of that kind of stuff. You provide the logistics and the transportation. Basically go to a company and say, what business do you want to do in space? We'll take care of the space part.
So when we think about another space station in the future, there's going to be different ways to get there, I'm sure, and one of them is Dream Chaser, product of Sierra Space, and that's really your project, right? That's your current project that you're working on.
In matter of fact, 24/7 production on the first vehicle right now. And we plan to fly first quarter of 2023.
Oh my gosh, well, we have one here, so let's go look at it.
Looking at all the airplanes I flew, and then the ones I didn't get to fly. I flew that one, I've flown that one, I've flown that, I've flown that, I've flown this guy. I've flown one of those too, yeah. So the Dream Chaser is a what's called a lifting body spacecraft. It's what we're working on, it's what we're building right now that we intend to fly in early 2023. What it is a lifting body spacecraft. And what that means is most airplanes, the wings provide the lift. I think most people know that. But in this particular vehicle, it's the body of the spacecraft itself that provides the lift, and only a little bit comes from those wings. So it looks like a mini space shuttle, right? So it's designed to launch on a rocket, fly up in orbit, rendezvous, dock, free flight, whatever you want to do on orbit, orbiting satellite, research platform. Then we enter, and when we enter, we see very, very high heating temperatures as we slow down, up to 3,000 degrees. That's why it's a blunt body. And then in the end, it comes down and it lands like an airplane. And so what I want is I want us, and quite frankly the whole world, to realize that commercial vision where space travel is routine. Multiple people going, thousands of people, tens of thousands of people working in space. I want to walk into a classroom as an astronaut and say, big deal. You know, half of our parents have gone to space.
Right,
Wouldn't that be awesome?
I think it's going to happen.
It will happen.
Yeah.
And we're doing everything we can to make it happen as soon as possible.
This was all kind of theoretical, even only 4 years ago. And now suddenly it's real, right? You've been to space already.
Going to space was life-changing. It really was. And as much as I told myself I shouldn't have expectations going into it, I really did. And those expectations were high, and they were just completely smashed. I mean, it was so much more profound and transformational than even I had hoped. So you're in the capsule about 35 to 40 minutes. from the time they put you in to the time they take you out. So you're on the pad, and you would think you would be terrified, and you would think you would be scared, at least I thought I would be, and I really wasn't. So then you get to countdown, right? T-minus 10, which is like the classic space, 10, 9, 8.
7, 6, 5, 4, command engine start, 2.
Well, huge congratulations to all 6 crew. They have crossed that Kármán line and they became official astronauts.
You get to space and they do main engine cutoff, and then you're kind of floating in your chair, but you're held back from your harness. And then they do what they call capsule separation. But then you're able to unbuckle.
Cue the astronauts to unbuckle their harnesses and start floating around the capsule.
They are in 0G, they've practiced for this, and now it's really happening.
I had the privilege of going to the window and I turned myself upside down. And I did that intentionally to sort of disrupt my orientation of up and down. I looked out the window, I gasped. You're seeing the Earth from space, totally transformational, extraordinary. And then from there, you get back in your seat. That's quite important, because what's going to happen is as you go falling back down to Earth, you hit the atmosphere. And then you come on down, and then the first thing that happens is your drogue parachutes open. Those basically guide and settle everything down. Then you have the main parachutes deploy. Then once you land, they give the crew a private moment to huddle and hug each other and just bask in the experience that we just had together. And then they open the capsule door, and you're greeted by hundreds of press and your family and loved ones. It is shocking how much we were able to get done in 2021. The technologies have matured. I think I was number 606 human to go to space. I'd like to have 606 humans per year go to space. And I don't think we're too far away from that. I think that'll happen in this decade.
With that in mind, you started Space for Humanity a few years ago. Tell us about that.
Yeah, so Space for Humanity was founded with really 2 primary notions. One is that we need to democratize access to space. It can't be a billionaire boys club. It can't be exclusively North American or white or anything. It's got to be human. It's got to be a human endeavor. And then the second core principle was the notion that space is a tool for transformation, right? It's a lot of things, technical challenge, investment opportunity, but it's primarily a tool for transformation. It's run by a terrific leader named Rachel Lyons.
It's so good to see you.
Good to see you too. Let's go.
All right, I'm excited.
Part of the original mission was to make space accessible to anyone.
We have entered, just over the past few years, this new era in space exploration, and this new era in space exploration is very much being led by the commercial companies. Up until 2021, we had 8 people go to space commercially, ever. And in 2021, we had more than 20 people go. What the numbers are saying right now is that in the next decade, 10,000 people or more will have been to space. And this can't just be for the ultra wealthy right now. The potential of this is much too big. And just in this past year, it opened up to so many people.
Organizations like Space for Humanity are making it possible for anyone to apply to go to space. So it's really, ideally, eventually, not just for the wealthy.
Just in the past couple of years, we've had so many firsts when it comes to who's going to space and how they get there. People like Eric Ingram with different abilities, whether physical or mental, whatever it is, these are people that before never would have gone to space. And now with Mission Astro Access, they're learning things they never would have thought of before.
I applied to be an astronaut twice, knowing full well I would not be accepted. Imagine how many people aren't applying to be astronauts because they don't think they can meet the minimal requirements. As a species, we are at the very beginning of human spaceflight. And when you're at the beginning of something, it's the easiest time to design for things. And so Astro Access was founded to make sure that anyone can go to space when that opportunity presents itself. And so we flew our first parabolic flight in October of 2021, where we took a plane and we did some parabolas where we were able to experience microgravity and lunar gravity and Martian gravity, and able to test some awesome technologies and ideas we had for making space more accessible to everyone. I think what you're seeing with commercial launch companies and commercial space stations and all that is more opportunities for that larger set of the human race to be able to finally go.
Truly believe it. I know it's cliche, but you got to see it to be it. I mean, I know I didn't have that to see, and so by me being the first, maybe that'll make some other little kids say, hey, I don't have to be an astronaut, I could be a suit tech. There's space for everyone. It really is, and I truly believe that. I mean, I'm a prime example of it.
Startups are changing accessibility and sustainability in space, and even what it means to be an astronaut.
And next episode on Behind the Wings, NASA and other players in the space industry set their eyes on the moon and beyond. Talking about Mars.